All right, welcome again to SAMI and Mathematics. We've been doing a lot on calculus, and some student came around and said, just solve some questions, just solve some elementary calculus problems for us. So I got in my mail, some questions, and also I got in past questions, some questions I want to discuss with you. The first has to do with limit. So the first problem you see here has to do with limit. The second has to do with derivative, and here has to do with its application in dynamics and in motion problems. Okay, so let's just start with this. A typical question, we are always tempted to substitute values in limit questions. I want to say in some cases it may be uncomfortable. So what do we do in this kind of case? We can't just substitute. If we substitute here, you're going to have an indeterminate case where we have to apply the LOP2 rule. Because if we substitute 1 here, you're going to have 1 minus 1, which is 0. And if you substitute 1 here, you're going to have 0. So this is going to give you 0 over 0. So we just have to do something. So we are going to look at this function. We have limit as x tends to 1 of 1 minus x divided by x squared minus 3x plus 2. So what do? We can apply the algebraic method to see if we can factorize the denominator of the rational function. How do we do that? We factorize this, and that will give us limit as x tends to 1 of 1 minus x, and this can be factorized into x squared. Remember your elementary factorization. This can be factorized into minus x plus 2x. Sorry, minus x minus 2x and plus 2. So we can do this. I believe in this. It's elementary. We look for two numbers that can multiply to give us 2. That is minus 1 and minus 2 can multiply to give us plus 2. And minus 1 and minus 2, if you add them, it's going to give you minus 3. So we have minus x minus 2x giving us this minus 3x, and we have 2 here. So this can be factorized to give us 1 minus x divided by, I'll factorize this. What is common here is x, and this you are going to have x minus 1. What is common here is minus 2. And you're going to have also x minus 1. So this is going to end up giving you limit. So I can rewrite this as x minus 1 divided by x minus 1 and x minus 2. So I can factorize this to give me this. Remember, x minus 1 is common, and I have x minus 2 left there. I can also reverse this so that minus times this is giving you this, and minus 1 is giving you this. And this can cancel this. And if that happens, what is left is limit, okay, bring out the minus sign of 1 over x minus 2 as x tends to 1. This as x tends to 1. So if you substitute this limit, we are going to be having minus 1 all over x, 1 minus 2, and that is going to give us 1 all over minus 1, so everything is just going to give us 1. So that means the limit of this function as x tends to 1 is equal to 1, but can't we, let's apply the LOP2 rule. So if we apply the LOP2 rule here, we can differentiate the numerator, and that is going to give us minus 1. So we can differentiate this. This is going to be 0, and this is going to be minus 1. If we differentiate this issue 0, you differentiate this between minus 1. Please try to check my video on differentiation, elementary differentiation, to understand that. Now, if we differentiate the denominator, this is going to give us 2x minus 3. 2x minus 3. So if we differentiate this 2, is going to give us 0. This is going to give us minus 3, and this is going to be 2x. And we have limit. Sorry, let me demarcate this. So we have limit as x tends to 1. So we can, by LOP2, we can substitute our value and have this to give us minus 1 over 2 into 1 minus 3. And that's going to be minus 1 over minus 1, which is equals to 1. So using the algebraic rule, which is actually so long, and using this other method, we will always give you the same answer. But in some elementary classes, they may not permit an operator rule, so you can always use the algebraic rule. But in the case where you cannot factorize this, you can use this method, and you have your answer. So we'll go to the next question.